combined or dual clipper. Sometimes it is desired to remove small portion of both positive half cycle and negative half cycle. In such cases, combined or dual clipper circuits are used. Now normally this combined clipper circuit is consist of one a bias positive shunt positive clippers and bias shunt negative clipper circuits. Now let us consider the circuit which is connected to the input AC supply. Here the load resistance is connected in series with the load resistance and diodes are connected in parallel. So during the positive half cycle, the terminal A is positive in compared to terminal B. Now the A terminal is connected to the anode of the diode D1 and cathode of the diode D2. Now similarly, B terminal is connected to the cathode of diode D1 and anode of diode D2. Now during the positive half cycle, the diode D1 is forward biased due to the input voltage, but it is reverse biased due to the battery voltage VB1. Now, on other hand, the diode D2 is reverse biased due to the input voltage and it is also reverse biased due to the VB2 voltage. On other hand, it doesn't matter whether your input voltage is less than or greater than this VB2 voltage. That means in both cases, the diode remains in reverse bias condition for the input supply Vi as well as battery supply VB2. When the value of this input voltage is less than VB1, remember one thing, this diode D2 remains in reverse bias condition. It is act as an open circuit during the whole positive input cycle. So we here the value of this input voltage is less than this VB1 voltage. That time this diode D1 it is also becomes reverse bias and it acts as an open circuit. So your input voltage, whatever input voltage, it is reflected on the output side or it is appear on output side. So you can see that during this period a positive input voltage is reflected on the output side. But when the value of this input voltage is greater than this VB1, the diode is said to be reverse biased due to the battery voltage VB1 and it acts as a open circuit and there is no current passing through this diode and whatever your input voltage, it is not appear on the output side. That time we will get only plus VB1 voltage across this output voltage. Remember, now when the value of this Vi is less than VB1, then this diode is reverse bias and it acts as a open diode and your input signal is transported to the output side. So this is this happens during the positive half cycle. Now during the negative half cycle, terminal B is positive in compared to terminal A. So this diode D1 is reverse bias due to the input supply voltage and it is also reverse bias due to this battery VB1 voltage. So it doesn't matter whether your input voltage is less than or greater than this VB1 voltage. In both cases, or the diode D1 remains in reverse bias condition due to the input voltage or the battery voltage during negative half cycle. Now due to this diode D2 is forward bias due to the input voltage and it is reverse bias due to the battery voltage VB2. When the value of input voltage, reverse input voltage is less than this VB2, this diode is said to be in reverse bias and it acts as a open switch and whatever your input voltage, it is reflected on output side. So you will get some negative voltage at the output terminal. But when the value of this input voltage the value of this input voltage is greater than this VB2, greater than this VB2, then what happened? What happened? This diode is reverse bias and it act as a open terminal, and that time whatever your input voltage, it does not appear on the output side, and we will get this VB2 minus voltage on the output side. When the value of this Vi is less than this VB2, again it will turn on the diode D2 and current start to flow through this diode, and your input signal is transferred or appears in the output side. Next, application of clippers. Now it is commonly used in power supply. It is also used in TV transmitter and receiver. It is used to generate square wave, rectangular waves or trapezoidal waves. Series clipper circuit are used as a noise limiters in FM transmitters. It is also used in radio receiver, and it is used in digital computers and radars.